Hello, everyone, and welcome to This Explainer. Whenever we stand on a platform or ride a train, we rarely think about what it actually takes to keep that massive, heavy machinery running smoothly. But more importantly, we almost never think about the incredibly complex, completely invisible engineering that keeps the people who maintain those railways alive. Today, we're diving into the fascinating technical and procedural interfaces that protect staff working right there on or about the track. It's this incredible story of human ingenuity meeting some really high-stakes physics. Let's get into it.
All right, so here is our roadmap for today. First, we'll look at the danger on the tracks. Second, implementing vital lockout facilities. Third, high-tech staff warning systems. Fourth, safety protocols and key switches. And finally, the ultimate fail-safe network.
Starting with Section 1, the danger on the tracks, navigating the hazards.
To really appreciate the absolute brilliance of railway safety engineering, I want you to mentally put yourself right in the shoes of a track worker. Imagine you've been tasked with inspecting a vital switch or replacing a piece of heavy equipment out in the elements. That brings us to this absolutely critical question. How do you actually stop a heavy train from entering a live work zone? I mean, think about the sheer physics involved here. A train can weigh hundreds, sometimes literally thousands of tons. It cannot swerve, there is no steering wheel. It takes a massive distance just to come to a halt. If you're a worker standing on the ballast fixing a point machine, a simple miscommunication could be catastrophic. The physical stakes out there are literally as high as you get. When you look at the complex trackside electrical infrastructure where these personnel actually operate, you realize how constrained it is. You've got heavy orange conduits, thick wiring, metal relay boxes everywhere. It's a highly technical, really tight environment. A worker's life out here depends entirely on robust technical and procedural shields. You simply can't rely on just looking over your shoulder. You need systems that absolutely guarantee a train cannot reach you. Which brings us to Section 2, implementing vital lockout facilities, or what are basically digital padlocks.
So, what exactly is a lockout facility? Well, these are systems that isolate specific track sections by interacting directly with the railway's interlocking. What this means in plain terms is that signalers can implement lockout zones or use specific reminder devices to absolutely guarantee a train cannot be routed into your work area. The interlocking, you can kind of think of it as the brain of the railway. Historically, this actually used to be mechanical, like metal bars physically stopping levers from moving. Today, it's all highly advanced electromechanical or computer-based logic. When a lockout is applied, the system fundamentally prohibits any signals from being cleared into that area, and it physically locks the track points so a train just cannot be diverted toward the workers.
Think about the two very different worlds that have to communicate flawlessly here. On one hand, you have physical track operations, trains moving in real space, much like the systems utilized in the Auckland Electrified Network or the UK Main Line. On the other hand, you have the control room, the nerve center, with these massive digital displays of the track layout. A patrolman out on the track communicates with the signaler in that room, and the signaler inputs controls directly into the interlocking. The digital command in that quiet room immediately becomes an unbreakable physical reality out on the rails. It's amazing.
The contrast between these states is just striking. In normal track operations, signals are flowing, trains are moving dynamically based on traffic management, and switches are constantly aligning to route that traffic. But in an isolated lockout zone, everything changes. Normal operations are entirely suspended. Signals are suppressed, sometimes just wrong direction signals, sometimes literally all signals in an area. The switches simply cannot physically move, ensuring maximum protection for the maintenance crew. It's like throwing a massive invisible fortress wall around a section of track.
Moving on to Section 3, high-tech staff warning systems, the eyes and ears out on the rails.
But okay, what happens when you have to work on or near a track where shutting down the entire line just isn't feasible, and trains are still operating nearby? Well, when the track is still live, the engineering completely shifts from isolation to hyper-awareness. Trackside warning technology acts as this unblinking spotter for the crew. The systems use approaching train detection to sense traffic miles before a human ever could. This triggers audible lineside alarms, and incredibly, these alerts can even be integrated directly into the staff's personal equipment. We're talking built-in warning tones inside their helmets. Plus, the system doesn't just warn the staff, it talks to the trains. By utilizing local inductive data links and the overarching train protection systems, temporary speed restrictions are strictly enforced the absolute second a train nears a work zone. This all builds into a much wider network. Automatic train protection, or ATP, interacts closely with signaling control and various inputs. These warning systems aren't just, a loud siren on a stick. They're deeply integrated into this entire ecosystem. The ATP equipment, whether it's trackside or trainborne, is constantly determining train location and movement authority. If staff are working, the system knows. It can actually interlock train movements with staff protection key switches and automatically slow trains down. It's this continuous, dynamic loop of safety data passing between the train, the track, and the worker.
All right, Section 4, Safety Protocols and Key Switches. This is all about physical authority.
This is where we talk about giving physical authority back to the workers on the ground. And one of the most fascinating fail-safes in all of railway engineering is the token system. An engineering token is a physical or digital authority ensuring only one entity can occupy a single line section at a time. I absolutely love this concept. Think of it exactly like a baton in a relay race. You absolutely cannot step onto that section of track unless you are physically holding the baton, period.
Let's walk through how this fail-safe process actually works in practice. So, Step 1, the worker or driver requests the token. Step 2, the heavily interlocked machines check the entire system to verify that the track section is completely clear. Step 3, only then is the token issued, becoming the absolute authority to enter that space. And finally, Step 4, when the work is done, the token must be replaced into a machine to clear the section. Because the token machines are interlocked, it guarantees that only one token can ever be removed at any one time. What's so brilliant about this is how it maximizes productivity. Gangs can quickly take possession of a track while achieving mathematically perfect safety.
And speaking of physical control, we also have on-track personnel protection key switches. These are physical interfaces located right at the trackside. They give the maintenance crew direct, unchallengeable control to lock out a work zone on the spot. By turning that physical key, the worker is actively changing the state of the interlocking we talked about earlier. They are literally putting their own safety into their own hands before they ever step a single foot onto the ballast.
Finally, Section 5, the ultimate fail-safe network, man and machine. When you have incredibly complex physical track wiring meeting the focused oversight of human operators in a control room, you realize something vital. Safety isn't just about having good software or thick cables. It relies on the perfect interlocking of human procedure and technical hardware. For instance, even with all this ATP and interlocking technology doing its thing, human factors, like strict rules for high-visibility clothing that specifically identify a worker's organization, are still absolutely mandated. The technology aids safe working for sure, but the human protocols ensure the technology is actually applied correctly. When you stack all of these systems on top of one another, you get something pretty extraordinary. From lockout zones managed by signalers, to trackside warning systems alerting workers and slowing trains, right down to token instruments and key switches, giving workers physical authority. These are the layered defenses that create a totally invisible, life-saving shield around the men and women who keep our railways running. It is a relentless, 24/7 engineering effort dedicated entirely to a zero-fatality environment. So, next time you see a train glide effortlessly past a crew working safely by the tracks, you'll know exactly how many invisible digital padlocks, sensors, and tokens are working in the background to make that possible. Which leaves us with a pretty fascinating thought to take away today. Look around you. What other invisible safety systems are protecting you right now, hidden just beneath the surface of your daily life? Thank you so much for joining me on this explainer. Stay curious, and I'll catch you next time.